Hi, Chris here for Tech and welcome to the channel. Well, today it's all about working with the active and passive buzzers. So let's get started now. So last week we learned all about the theory and the different types of buzzers, as well as how to use the active one. I also gave you an assignment and wonder if any of you managed to make it. Well, if not to worry, as I'll show you that and much more right now. For the setup, I will use the active buzzer, as we saw last week, and we will also use the RGB. If you want more details, you can see it here. So once the connection is made, then the assignment was, well, for above 1000, I want the red LED, in between 500 to below 1000, I want the orange LED, for 1 to 499, I want the green LED, and again, red LED blinking when it's 0. For those with a headphone, this is a warning for the volume. Okay, now let's see the sketch, starting with the RGB LED, and that's what those three integers are here. Under that, we have this set here for the buzzer and the delay. Then we declare and set our messages to display later. Lastly, we have declared our user choice. For our voice setup, we have our serial begin with a 9600 baud rate for troubleshooting, followed by the RGB with all its pins set as outputs, the same for the buzzers. Lastly, in the void loop, we start by printing the welcome message, followed by the while loop with a serial.print available, and not forgetting the user choice with a serial pass hint this time. Then, if the result is above or equal to 1000, we print out our messages, light up the appropriate LED, red in this case, and start the beeping. The next if statements look similar, but this time, if the value is in between 500 and below 1000, we print our messages before we set the appropriate color for our RGB, orange here. Then initiate the beeping sequence, and here we can see that we doubled our delay. The easiest way was to set up another delay with a different timing, but well, I did this instead. We finish by printing the user choice and the message tree. Then, if the result is above 0 but below 500, we print the message, set the RGB color to green and start the buzzing. Only one beep this time, before we had the user choice and the message tree. Lastly, if the user choice is 0, we will, after we print the first message, we start the color and blink the RGB as well as the beeping sound. Note how we do that. By setting both on or high, we add the delay before we turn them off and then repeat that. And you notice how we finish here by setting the light and the sound on, and of course the message for. Okay. Now it is time to send this to the Arduino to see how this works. Okay, let's put the diffuser to see the color a little bit better. I take this opportunity to show you the sketch, and that's how it looks like with two delays. Okay, so let's close this, and it's this sketch here, which is very simple. You can see we simply have the buzzer on pin 8. Then we have two delays for the timing, one at 1 millisecond and one at 2 milliseconds, and then we have another timing. This one actually it's a delay. So for our voice setup, we have almost nothing, just the pin mode set as an output here. In the void loop, we have the buzz pin high, the delay time number 1, the buzz pin low, the delay time number 3. We then turn on the buzz pin to high with the delay time number 2, And after that, we simply turn the buzzer off with the delay time about 3. Let's send this to the Arduino. And oh, you know, you're familiar with that. Okay, so what we can do now actually is select all and paste it. This time, as you can see, I had the RGB back. Alright, and of course I set it as output. And you guess what color it has? Let's send it and see if you are correct. And yes, that's correct. I like it. Anyway.
But wait, there is more.
Continue this trend with a sketch and discover other way we can achieve this. So if I select all and paste our next code like so, at first glance not much has changed. But let's see what's the difference with it. Our delay time 2 has changed from an integer to a float, and the timing now is 0.08. Next, it's our delay time 3 has changed to x only, and that will be used as a counter to allow our for loops to work properly. Let's see if this code does as before. What do you think will happen? Let me know in the comment down below if you think you know. Yep, that's right, got a different tone. How many of you thought of that, I wonder? Okay, this is annoying. Let's change that to a 2. Like so. Yep, still the same, still annoying. But at least now we have 2 times the tone. And it's not because of the for loop. If you want to know more about the for loop, you can watch this video here. So I will unplug this, okay, because we have other things to do. Alright, now this is done. Oh, that's much better, isn't it? As you witness, we managed to make a 2-tone sound with the active buzzer. And now, let's try something different, keeping the same sketch and connections. Of course, remember, the Arduino is still unplugged, hence no more this stressing sound. So, we can swap the active buzzer for the passive one. That's being the only change we will make to the circuit. Well, if I can, that is. Yes, there. We still need to mind the polarity, of course, like so. As if you remember in my previous video, I was speaking about this small sign here. Oops, sorry about that. Okay, I was speaking about this small sign here. Let's continue anyway. Moving that out of the way for now, and adding it into the breadboard before we plug back in the Arduino. Well, if I can, that is. Yes, there. Well, why not arrange this? Oh, and that too, as well. Okay, let's see what we will get. Here it goes, nothing. That's strange, there is no sound, but you can see the light is still blinking. Let's see why. Maybe I plugged it wrongly. So let's try to move it a little bit, like so. And I think I may have overshoot by 1. How do you call that in English already? I forgot. Oh yes, 1 notch. So let's reposition it there and see how is it. Ah yes, I plug it wrongly, you see? Alright. It's not as annoying, actually. You can see that the passive buzzer is louder. Okay. I think we have enough of that, so I plug it back. Because I want to go into the sketch and see something else. Now we will learn an even more interesting function that we can use with the passive buzzer called delayMicroseconds. And it is actually allows us to divide a millisecond by 1,000. This should be interesting. And as you can see here right now on the screen, this is where you can get more information. Don't worry, you will find the link in the description down below for you. So, to understand better how this works, let's try something like so. I'm changing now all the delays for the delayMicroseconds. Like so, okay? Now that we change it that way, this is actually similar as before. But just to establish a baseline, let's send this to the Arduino and check that. Yes, it works. The things to understand is now that we have a wider range to play with. Let's see how this sounds. Warning again, if you have your headphone on. Now, how can we make this useful? Well, it's simple. We will add this potentiometer and we will set the buzzer to have a tone of 60 microseconds delay with the green LED on. And this could be the temperature represented by the potentiometer here, being all the way to the left. Then, when the temperature is half the range of the potentiometer, being in the middle, the tone change to 800 microseconds and the green LED will switch to an orange one. And finally, when the temperature is too high, represented here with the potentiometer being all the way to the right with a 10,000 microseconds delay, and the LED will be red and blinking. Spoiler alert here, in order to do this, we need to do some math. I will cut it short. You may want to look at this video here, which was with the if statement. If I'm going too fast, you can find the description in the link down below, where we go into details on how to find the slope. Okay, let's put this with a variable that we can actually use, like so. Alright, we can say that our tone is equal to the slope 9940 over 10,023 multiplied by x minus 0 times pot val, and we don't forget to add the 60. Now we are done with that equation. All we have to do now is to put our middle value. Although we can calculate it, we will simply take a rounded value of 512 for that. I'm sure you get it why. Excellent. Now we put this into the code, we materialize this. And there it is, guys. You can see it's working. Here it's green with a correct sound, and here it turns orange. And if I go further, like so, now you can see it's red. Now, if you want to know more details about the math behind that, just leave me a comment down below and I might do a video on this. I just don't want it to be too boring for you.
That is it for today. Thank you for watching the video. And just to let you know, I started a Patreon where, if you want, you can support me. And again, if you enjoy it, you know what to do. You can do your YouTube things, like, if you want to, subscribe, you may as well. Or you can also press the bell icon if you want to be notified every time I post a new video. However, if you do not like this video, simply leave a comment down below and tell me why it's so. I will try to do it for you guys. Stay safe and bye now!